We're looking at mixed exercise 9 from the first year core textbook on trigonometry. So what have we got here? So we've got a park keeper walking, so that's his starting point. He walks 1.2 kilometres due north to B. And there's our bearing of 110 degrees. And how far is he? Okay, so the fact they've given us a sketch of this does make part A not too bad, because basically, how far is he from C? Well, he went 1.2 that way. So the only little calculation we've got to do before we can start using our trig is to say, well, look, if that's 110 degrees and that was due north, that's just going to be a 70-degree angle there, because obviously angles in a straight line add up to 180. And I know that that's 1.4. A is where he started. So all they're really asking me for is the length of that side of the triangle. So that's going to be cosine rule. That's going to be cosine rule. And let's call that missing side x. So x squared is 1.2 squared plus 1.4 squared minus 2 times 1.2 times 1.4 times cos. It's just going to fit cos 70. Okay, so that's all going. In fact, I can just type that all in one go. Just be careful with pluses and multiplying. So 1.2 squared plus 1.4 squared times 2 times 1.2 times 1.4 times cos of 70 is giving me 2.25. So if I square root that, I would get x is 1.50 to 3 significant figures, and that's in kilometres. Okay, let's just check that. It's quite a long question, yeah, 1.50. Okay, work out the bearing of the hut. So where is the hut? Hut is, right, so the hut is at A, where he started, and we want the bearing of the hut from C. Okay, so that's fine. So there's the hut. Okay, we want the bearing from C, so we're measuring from due north at C. So we want that angle there. Okay, so we can get that angle from trig. In fact, we think we can get that using sine rule. And I can get that angle from thinking about parallel lines. So let's get the green angle first, because that's actually the easier one, although it might be the less obvious one. Okay, so remember back to your angles in parallel lines. I've actually got, not their technical name, but I've got a Z angle there, or an alternate angle as they should be called. Okay, so that just means that green angle is 70 degrees. Yeah, I know, totally looking, I think my red arrow at C is not particularly north, but if they're parallel, which they both are because they're both due north, then I've got alternate angles there. Okay, so so that angle there is 70 degrees. So if I can get the blue angle, I can then take it all away from 360 and get the red angle. Okay, so blue angle, I'm going to need to use trig, but I can use sine rule, which is sort of generally not too bad, because I've got that side, so that angle and that side. So I now know that that side is 1.5 or 1.50. And then I've also got that side, so I can use sine rule and say that, so let's call this angle here, we're trying to find theta. So I can say sine of theta over 1.2 is sine of 70 over 1.5 or 1.50. Okay, so sine of theta is sine of 70 over 1.5 multiplied by 1.2. Could put this into a calculator, but it's actually easy just to do it all in one go. So theta is inverse sine or arc sine of all of that, which is, so, and again, I haven't actually cleared the 1.50 for my calculator, so I'm going to use the exact answer for that. So I want to do sine 70 divided by that previous answer times 1.2, and then the arc sine of all of that. So I am getting theta is 48.7 degrees. So that is this angle here. So I'm getting that as 48.7. So that red angle is just going to be 360 minus the 70 degrees we worked out, minus the 48.7. And then because it's a bearing, yeah, actually we shouldn't have to worry too much about accuracy because it's a bearing. I'm only going to give it to 3 figures anyway. Okay, so again, I'm going to check that there, just make sure, yeah, we're good. Okay, and then the area enclosed by his walk. So yeah, that's quite good. This is worth 3 marks. I think this is probably the easiest bit if you've got this far. So area of a triangle. I'll tell you what, let's just draw out again, quicker. Okay, so what do I have? Well, I have 1.2, 1.4. I always knew that was 70, and actually, I don't need. Oh, sorry, let's see what I'm writing. So that's what I had in the original question. Yeah, 1.2, 1.4, and then that angle must be 70. And that's all I need for the area. So that's quite good because it means I don't have to rely on any of the angles I've calculated or any of the lengths I've calculated. So area is half times 1.2 times 1.4 times sine 70. So half AB sine C. So let's go to the calculator. Sine 70. Oh, yes, that's quite a low answer, but I guess that does make sense. So if I give that to 3 significant figures, yeah, I mean, I guess if that's square kilometers, that's actually still quite a decent area. Just to make sure I did read that. Work out the area enclosed by his wall. Yeah, that's the area of the triangle, isn't it? Double check.